Hey you guys, so today I just put together a video for you to go through all the problems that are on your 5.1 to 5.3 test review. So you've got a test coming up. So here is each problem worked out step by step for you. Hopefully this helps you a little bit. All right, so first one, we're asked to convert 3,200 inches per second into feet per minute. And we're going to round answer to same accuracy as original measurement, which means since we've got two significant digits in 3,200, our final answer should also have two significant digits. So there's actually two different conversions that we need to do. The first thing is converting our unit of time. So 1 minute is equivalent to 60 seconds. So because our current rate is in inches per second, we want to convert it into per minute first. So because there are 60 seconds in a minute, we're going to start by multiplying by 60. So 3,200 times 60 is going to give us 192,000 inches per minute. I'm not done yet because we want feet per minute, not inches per minute. So the last thing we're going to use is knowing that 1 foot contains 12 inches. So to convert our inches to feet, we're going to divide by 12. So our last step is to take that 192,000 and divide it by 12, which gives us our final answer of 16,000 feet per minute. All right, next one. So we have got a hole for a bolt is measured at 0.917 inches. Two parts to this. We want to figure out what size bolt to the nearest 16th of an inch is going to fit into that hole. And what is our error to the nearest 10,000th of an inch? So first, we're going to convert our decimal that we're given into a 16th of an inch. So to do that, we take our decimal over 1, and we're going to be multiplying it by 16 over 16, which is just like you're multiplying it by 1, but this is going to allow us to have a denominator of 16ths of an inch. So multiplying your tops, multiplying your bottoms, here's what you get. Now, this is representing the size of the bolt that we want to fit into that hole. So we are going to be rounding down to the nearest whole number for this one because we want the bolt to fit in the hole. So 14/16, which would also reduce to 7/8 of an inch. That is the size bolt that would fit into the hole. So next up, we're going to calculate the error. So error is how far off is our estimation, so in this case 7/8, from the original measurement of 0.917. Oh, yeah, there's the answer for that. So we want to find the difference between our estimated fraction of 7/8. What's the difference between that and the original measurement that we were given? So you're just going to take 7/8 minus the original decimal. So 7/8, if we were to do 7 divided by 8, we would get the decimal equivalent of 0.875. Subtract off the 0.917, and we get negative 0.042. All right, so 42 thousandths of an inch. Now, our error is always going to be given to us as a positive value because we're just saying what is the difference between these two values. So even though we got a negative here, I'm still going to report the error as a positive value because error is always given as a positive number. So the error then is about 42 thousandths of an inch. All right, next up. A 2018 Kia Stinger has 3.8 liter engine. We want to figure out the size of that engine in cubic inches. And we're going to round to the same accuracy as original. So our original has two significant digits. So our final answer will also have two significant digits. So for this one, there is no direct conversion from liters into cubic inches. So we're actually going to have to go through cubic centimeters in order to figure out cubic inches. So this is going to be a two-step problem. So first, looking at my conversion chart, I see that 1 liter is equal to 1,000 cubic centimeters. So here's how I'm going to set up my first proportion, keeping the liters on the left, cubic centimeters on the right. I'm trying to figure out cubic centimeters. Cross multiplying and dividing, I get 3,600 cubic centimeters. All right, so I know how many cubic centimeters are in this engine. Now, finally, we need to convert that into cubic inches. So here's the conversion we're going to use. 1 cubic inch is approximately 16.387 cubic centimeters. So using that 3,600 cubic centimeters that we just calculated, here's our final proportion. Keeping our cubic inches on the left, cubic centimeters on the right, cross multiplying and dividing. We get a final answer then of about 220 cubic inches. And again, we wanted to round that to have the same number of significant digits as the original. So the original had 2, so our final answer will also have 2. All right, next up, this one should hopefully be pretty quick. We're converting 195 pounds into kilograms, rounding the same accuracy. So again, we're starting with 3 significant digits, so our final answer should also have 3 significant digits. Using our conversion chart, we find that 1 pound is equal to 0.4536 kilograms. Setting up our proportion, I'm keeping pounds on the left, kilograms on the right. I'm trying to find how many kilograms are in 195 pounds. Cross multiplying and dividing, I find that we get about 88.5 kilograms. And again, rounded so that our answer has the same number of significant digits of 3 as the original. So there's our final answer. All right, switching to the back side of the review. So now we are converting 8.35 inches into millimeters. There is no direct conversion straight from inches to millimeters that we are given in our conversion chart. So we are going to have to go from inches into centimeters first, and then we'll be able to convert centimeters to millimeters. 1 inch is approximately 2.54 centimeters. Here is our first proportion, keeping our inches on the left, centimeters on the right. Solving for our centimeters, cross multiply and divide. We get 21.209 centimeters. Now that I know how many centimeters are in 8.35 inches, I'm going to do one more conversion, then changing those centimeters into millimeters. 1 centimeter is equal to 10 millimeters. So using that 21.209 centimeters in my proportion, here's the setup. Cross multiplying and dividing, then I find that final answer, we get about 212 millimeters. So 212 millimeters. And again, we want to match the number of significant digits of our original. Our original had 3 significant digits, so our final answer should also have 3 significant digits in it. So 212 millimeters. All right, next, we're converting 95,000 centimeters to kilometers. We're not going to be rounding this time. And probably the reason we're not going to round is we're staying within the metric system. So our final answer is going to be nice and clean. There's not really any reason to round in this case. We're not given in our conversion chart direct from centimeters to kilometers. So first, we are going to be converting our centimeters into meters. So if 1 meter is equal to 100 centimeters, we've got 95,000 centimeters. We're going to solve for how many meters we've got first, which would give us 950. Then finally, we're going to convert those meters into our kilometers. So using the 950 meters that we just solved for, here's our final proportion. Solving for how many kilometers then are in 950 meters. So our final answer is 0.95 kilometers. And again, we're not rounding, so 0.95 kilometers is perfect. All right, next up. This one's going to be really similar to the bolt problem on the front side of the review. We've got steel pins available to the nearest 32nd of an inch. We're going to figure out the pin that's going to best fit in a hole that's measuring 1.841 inches in diameter. And we'll be reducing our fraction to lowest terms. So this one's going to be really similar again to that bolt problem, but now we're converting into 30 of an inch. So we're taking our original decimal over 1, and we're multiplying that by a form of 1 of 32 over 32, because we want to get it into 30 of an inch. All right, multiplying the tops, multiplying the bottoms, here's what we get. And again, we want the steel pin to actually fit into the hole, so we are going to round down to 58/32. Then finally, I'm going to rewrite this as a mixed number. 58/32 is the same as 1 and 26/32. Or finally reducing the 26/32, we would get 1 and 13/16. So that is the size 1 and 13/16 inch steel pin that is going to fit. There's our final answer. All right, next. This one should also be pretty quick. We are going to convert square feet into square inches. We're staying within the US customary lengths, or rather areas. So finding that conversion, 1 square foot is equivalent to 144 square inches. We were given 25 square feet. We're converting that into square inches. So we should end up with more square inches than square feet because square inches are tinier than square feet. Cross multiplying and dividing, we get 3,600 square inches for our final answer. And we didn't really need to round in this case, but we started with 25, so 2 significant digits. Our final answer also has 2 significant digits. All right, last one. This one's kind of the oddball of the group. So we are using our temperature conversion chart, which is on the back side of your Chapter 5 conversion sheet. So we are given a temperature of 25 degrees Celsius, and we're figuring out about how many degrees Fahrenheit that is, rounded to the nearest degree. So I'm just using one of those several temperature gauges on the back side. Look at those thermometers. You're trying to figure out degrees Celsius, and we want 25 degrees Celsius. So we're going to line that up. Here's 25 degrees Celsius. Here's where it lines up on the other side of degrees Fahrenheit. So down here, we're at 75. So we get 76, 77. So the temperature then in degrees Fahrenheit is about 77 degrees Fahrenheit. All right, that's it. I hope this helped you guys a little bit prepare for your test, but if you have any other questions, let me know. Otherwise, I hope to see you tomorrow.